Hello, so this is a Panasonic 7630 console, and this particular device doesn't turn on. So you can see the model here, KX-T7630 console. This console is used for TD100. You can see here on it also is Panasonic KS7630. It works with Panasonic TD100 pabx machine, and this particular device doesn't turn on. So I'm going to repair it and hopefully bring it to life so that we can use it again. These phones are expensive in the markets now. So what I'm going to do right now is just to open it up and see what is inside, assess the components, and hopefully identify a fault on it, then repair the fault. So come along with me. If you haven't done already, like and subscribe to the channel. We have good videos on how to fix all kinds of office equipment, from pabx to laptops, printers, phones, scanners, cameras, and access control doors. So before I can do any repairs on this particular device, the first thing I want to do is to open the device up. And to be able to do that, I have to remove all the screws at the back of the device. All the screws that are holding the device in place is what I'm going to remove. So this is what it looks like inside. This is the main motherboard inside. So before we do anything, I will remove this particular flex here, and you have to remove it carefully because it is very thin flex, and if you apply too much pressure you might actually break the flex. So that is why you have to be very careful when handling this particular flex. So after detaching it, I am going to read some of the components with my multimeter. One of the devices you have to get in place when fixing a device like this is your multimeter, and you must have basic knowledge of tiny components to be able to identify them and how to read them with a multimeter. Do I have that in my other videos on the channel, so you can just check how to identify components and how to trace a fault on the motherboard. So you can see this clip is actually attached to the handle of the phone. So I'm going to just detach, for safety purposes I'm going to detach all of these cables that is attached to this motherboard, because I might be using soldering iron and multimeter, so I don't want any form of interference on the subboard or any other components that is attached to this motherboard. So I'm going to check if there's any screw that is holding the logic board down, and at this particular point all the screws holding it down is out. So I'm going to assess the other end of the logic board to see what is going on around there, if there's any physical damage. The first thing you have to do when repairing a device like this is to first check for a physical damage, things you can see with your eyes before you attempt any form of repairs. Check for physical damage and replace that particular device that is damaged. Okay, this is the logic board. I am going to set my multimeter and then trace some of the fault on this. Now I'm going to set the multimeter to be able to read direct voltage, DC voltage. I want to check if the voltage passes through this particular port and where it gets to. This device can take from 50 volts downward. That is what the device takes, and that is what your pabx supplies. The pabx supplies from 50 volts downward. Some of them, by the time it gets to your device, it might be has reduced to 22 volts, 27 volts, 30 volts, 35 volts, 37 volts. But basically from 50 volts downward, that is what this device is built to take. So any voltage higher than that might actually destroy the device. So you have to be very careful with the kind of voltage that is coming into the device. So now this particular device here, I just want to read the device to be sure that there is no static charge anywhere, and then that this particular device can store and release voltage as and when due on the motherboard. Then I'm going to check these two capacitors also, and then I'm going to check this chip also. So these are very crucial components, and you must know how to be able to troubleshoot them. So the first thing you want to do when you want to troubleshoot these capacitors is, first of all, check for physical damage. Right now there is no physical damage, but I'm not going to judge by that. I will still do my normal testing just to be sure that there is nothing wrong with any of the device on this particular machine. So now I'm going to get my multimeter and set it to continuity just to be sure that there is no short circuit somewhere, and the part that is supplying voltage to the different components on the board is not broken in any way. Once the part is broken, it is hard for voltage to go to certain components, and when components don't receive the right voltage, they won't be able to function properly and your device will not turn on. So I am going to check for continuity right here, and this is the first port, this is the middle port, and then just like that. Okay, let me set the camera well, just a minute. Oh, okay. So like I said, this is the middle port, and then this is the first port, and then the middle port serves like an auxiliary. Let's fix it, and so you can see this is to telephone, and then this is to the pabx, and then the other one is for the handle. This is to the pabx. So that is very, very crucial. So all my troubleshooting will actually revolve around this particular port right here, because that is where that is the port that receives the voltage coming directly from your pabx, and then this capacitor is going to process it and then supply it to the transformer very close to the capacitor. So what I'm going to do right now is to first check the pathways just to be sure that the pathway is not broken, and then it's supposed to supply some volts to the capacitor and then to other devices. You can see these two cap lock here. These two capacitors rather, I am going to be checking the two capacitors also to be sure that they are functioning the way they ought to function. So while working with capacitors, you you have to be very careful because normally we are taught that once a capacitor is bad, most of the time it's swollen or is broken. But sometimes the capacitors can look very good and still be bad. So I just want you to have that at the back of your mind. So now let's test the component for continuity. So I'm going to be checking for continuity from this particular port right here that receives voltage from the pabx. So yeah, I'm going to set my multimeter just like I said earlier to be able to read continuity. So let's see continuity here. Okay, there's continuity here. So from this particular pin in this port, so there's supposed to be a part that is connecting this to this particular device here, very close to the capacitor, then the transformer. Then the transformer is going to transform the voltage so that other devices surrounding the transformer can be able to get the right voltage that is due to them. So like you know, the transformer doesn't receive direct voltage from your pabs. It goes through certain capacitors to be able to stabilize the voltage for it to be able to transform it. So I'm going to check for continuity run to be sure that the pathways for distributing those voltage is not broken in any way. So I have been able to trace there's a break in this particular logic board. So I have been able to sort out that break, but that was just off the camera. So that was a break in the continuity, supplying voltage to particular capacitors on the left hand side, if you take note. So that particular part is broken, so I have been able to rejoin the pathways, and then hopefully the problem is solved. I am going to power this device on now, and then hopefully it works the way it ought to work. So I'll just connect this device and see if this works. Wow, you can see it came on, which means that the repair actually works. So thank you for watching, and I wish you good luck with your own device. Thanks.